Hello, everyone, and welcome back for another math lesson. Make sure that you have your math journal and a pencil ready just in case we take some notes. Let's begin.
What's up, everybody? Mr. Sawicki here, and I can't wait to get started. I got a great problem to kick us off today.
All right. The first question on the screen says skip count by threes 4 times. Skip count by threes 4 times. Notice the way they wrote the number 3 and then a comma, and then there are 3 spaces. Please model this exact problem in your Nearpod starting with the number 3. All right, well, let's start by skip counting by threes 4 times. 3, 6, 9, 12. How'd you do? All right. Draw an array to match the count below. Make 3 the size of each row. And so we are going to create an array, and each row is going to be 3 units. 1, 2, 3. So here is 3, 6, 9, and 12. All right, guys, let's go. How many rows and how many columns does your array have? Let's start with the number of rows. In your Nearpod, please tell me how many rows you see. Well, let's remember that our rows go straight across. Rows go straight across. And there are 1, 2, 3, 4 rows. You should have stated that there are 4 rows. Now in your Nearpod, please tell me how many columns you see. Remember, columns go up and down. 1, 2, 3. In this array, there are 3 columns.
How many rows and columns does this array have? Kayla?
4 rows and 3 columns.
That's right. Ethan, we counted 3, 6, 9, 12. How does that array show the count?
Because 3, 6, 9, 12 is 4 threes. And this array has 4 rows of 3 circles.
Nice.
All right, so now we're going to rotate our array. How many rows and how many columns does the new array show? In your Nearpod, please tell me how many rows you see. All right, well, let's remember that rows go straight across. There are 1, 2, 3 rows. Now, in your Nearpod, tell me how many columns. Well, columns go straight up and down. 1, 2, 3, 4. This array has 3 rows and 4 columns.
Kayla?
The new array has 3 rows and 4 columns. In the first array, the 4 threes were 4 rows of 3 circles. And in the second array, the 4 threes were 4 columns of 3 circles.
That's right. Ethan, did the total number of circles change?
Nope.
So, I'm hearing you guys say that the total and the factors stayed the same. The factors just switched places. Recently, we learned a special name for that. What's it called?
Do you remember what the special name is when the factors switch places but the total stays the same? Is it the commutative property or the additive property? Please answer in your Nearpod at this time. When the total stays the same and the factors switch places, we call this the commutative property.
Now, Let's use the commutative property to write two multiplication sentences for the array.
All right, guys, so let's write two multiplication sentences for this array. Let's go ahead and you're going to write both multiplication sentences in the Nearpod at this time. Start with a multiplication sentence that models the array as you see it here. All right, so our first multiplication sentence, we're going to model out of exactly what we see here. This particular array has 1, 2, 3, 4 rows and 3 columns. And if we skip count like we did originally, we know that 4 times 3 is 3, 6, 9, 12. Now, the commutative property tells us that we can switch the factors and our total will remain the same. So your second multiplication sentence is 3 times 4 also equals 12.
Ethan.
One sentence I wrote was 4 times 3 equals 12, since there were 4 rows and 3 columns.
That's great. And Kayla, what's the other multiplication sentence you could have written?
We could switch the factors and write 3 times 4 equals 12, since there are 3 columns and 4 rows in this array.
Biggity bam.
All right. It says we know that we can count by threes to find the total. What other skip counting could we use? In the Nearpod, tell me, I can also count by blank to find the total. What else could I count by to find the total? Answer in your Nearpod now, please. Did you say 4s? Well, because our Nearpod, when we flip it over, now has rows of 4, we could also count by 4s to find the total. Let's skip count by 4s. If the first row is 4, what is the second row? Tell me in your Nearpod now, please. That's right. The second row is 8. What is the third row? Tell me in your Nearpod. That's right. The third row is 12. When we're counting by 4s, 4, 8, 12.
Kayla.
I would count by 4s. 4, 8, 12.
I love it. I think you guys are ready to try one on your own.
All right, everyone. So remember, when they pull up the Zearn note sheet, that means that we are going to pull out our math journals. Please make sure that you have your math journal out and ready to go and your pencil ready to write. Let's begin. At the top of your notes, we are going to skip count by threes 6 times. On your note sheet, I want you to skip count by threes 6 times. Teachers, please feel free to pause the video to allow the students an opportunity to skip count by threes 6 times. Now, on your notes, you should have written 3, 6, 9, 12, 15, and 18. Now, we're going to draw an array to match the skip count above. We are going to draw an array to match the skip count above. Now, keep in mind that each of our rows are going to have 3 in them because we are counting by 3. And we are going to have 6 total rows because we did this 6 times. Please pause and create your array now. All right, well, let's take a look at the array. My array has 3, 6, 9, 12, 15, 18 circles. There are 6 rows and 3 counters in each row. Now, please write 2 equations that match this array. Please pause the video and write your equations now. Well, let's check them out. We could first write an equation based on our rows and then our columns. We could also write an equation based on what this array would look like if we flipped it.
Ethan,
3, 6, 9, 12, 15, 18.
awesome. Kayla, take it from there.
Since I had counted 6 groups of 3, I drew an array that showed 6 rows of 3 circles.
Nice. Ethan, finish it off strong for us.
I knew from the commutative property that I could write 2 multiplication sentences for the same array. So first I wrote 6 times 3, which I know is 18, to represent 6 rows of 3 circles. Then I switched my factors and wrote 3 times 6, which is also 18.
Yiggity yow.
All right. And so go back and check your work and make sure you have all of this in your notes. Teachers, please pause the video and give the students an opportunity to check their work now. Let's keep moving.
High five if you got it right. If you made a mistake, it's all good. The good news is that I've got another problem to give you another chance.
All right. And so first I'm going to start by drawing an array that shows 5 rows and 3 columns. So I'm going to draw an array and it's going to have 5 rows and 3 columns. So I'm first going to model my rows. 1, 2, 3, 4, 5. And because I have 3 columns, that also tells me that there are 3 counters in each row. So I'm filling in my array now. All right, now it's time for you to provide some answers in your Nearpod. We are going to write a multiplication expression to match the array. When we write an expression, that means we do not have to give an answer. So please tell me how many rows times how many columns. You do not have to write the answer yet because we're just writing the expression. In your Nearpod, tell me what times what. That'll be your expression. Do that now. So this particular problem has 1, 2, 3, 4, 5 rows. So the number in the row box should be 5. This particular array also has columns, and there are 1, 2, 3 columns. Remember, guys, columns go up and down. So your expression should be 5 times 3.
Your array should have looked like the one here.
I wrote 5 times 3, since I knew there were 5 groups of 3.
Awesome. Now let's mix it up again and rotate this array and see what we can do with it.
All right, so let's rotate it. Boop, we flipped it. Please tell me what the multiplication expression is to match this array. Remember, expressions do not require us to give an answer just yet. Write the expression in your Nearpod. So now our array has 1, 2, 3 rows. Remember, rows go left to right. And 1, 2, 3, 4, 5 columns. Remember, we're just switching our factors because we're using the commutative property.
What's the difference between these two problems?
The array turned and the factors in the multiplication sentence switched places.
Yes. Ethan, why'd the factors switch places?
In the first one, the 5 is the number of rows, and the 3 is the number of columns. When the array rotates, there are 3 rows and 5 columns.
That's right.
All right, so now we've got to find the total, and we are going to skip count by 3s in order to do that. So the first row is 3. What is the next row? Tell me in your Nearpod. That's right, the next row is 6. In your Nearpod, tell me what the next row is. You guessed it, 9. What comes next? Tell me in your Nearpod. That's right, 12. And how many total counters do we have? Tell me in your Nearpod, please. That's right, 15. Now, let's rotate our array and count by 5s. The first row is 5. How many do we have by the end of the second row? Tell me in your Nearpod. That's right, 10. And the last row, please. You guessed it, 15. Now, let's solve for the total. In your Nearpod, please tell me the total number of counters that each array has. That's right, 3 times 5 is 15, and so is 5 times 3. The answer to both is 15. There are 15 total counters, and we found that out by skip counting. Now, the total in each array is it the same or is it different? Tell me your Nearpod now, please. That's right. The totals are the same.
Ethan.
3, 6, 9, 12, 15. So I know there are 15 circles in total.
Awesome. Kayla, how did you skip count to solve the second array?
I skip counted by 5s because there are 5 circles in each row. 5, 10, 15.
Nice work. Today we did some big time math. We worked with arrays to show the commutative property, and we saw just how useful skip counting can be in solving multiplication facts. Ready to show your skills? Then let's go to the Tower of Power.
Great job, guys. All right. And so now if you'll go to your Google Classroom, you'll find your exit ticket for today where you can show what you know from this particular skill. See you tomorrow. Bye-bye.